Hi, this is the CSSE220 final project presentation for Team 12. My name is Angus McKee.
And I am Reese Lewis. So today we will be going over our special features, our overall design, a few tricky bugs we had while coding, and some lessons that we learned while coding, and then our conclusion. So our first special feature is that our bullets speed up. So this increases the difficulty the longer the game is running to try and get the player to beat the level as quickly as possible. So as you can see, these bullets start off relatively slow, but they speed up once the game starts going for a while. Our second special feature is Horde mode. So this keeps adding in new monsters every second, and it keeps doing this for 45 seconds. So the objective is to stay alive for the 45 seconds, and if you survive the whole 45 seconds, you win the game. So in our code, how we got that to work was we had, for that specific level, the monsters would add the monsters in instead of getting the monsters we had set for the level. So we just continue to add them in instead of just adding it in the one time.
So now we're going to talk about like some of our previous design and now compared with our new design, how the things have changed from what we originally designed. So this design, as we look at it right now, looks fairly straightforward. We have a main class that points to the thing that creates our levels and all the various types that we had, including like the player and the different monsters and the different eggs that spawn from the monsters. And this class worked. In theory, it would work pretty well, but it also suffered from us not having as much wisdom as we have now, because we've been through and we've actually designed the game and we know what all is required in order to make such a thing work. So this is our current UML design. As you may notice, it's a tad bit more complicated. Our main class doesn't do as much work as we had in the previous design. Instead, it pushes a lot of the work to this main component. That main component takes care of pretty much the inner workings of the game, and it also does some of the functionality for the monsters and players, such as dictating when, based on some of the properties of the players and monsters, which one will die, which one will lose lives. And it also deals with level progression that comes from the level loader and all the designs that for the levels that come from said level loader.
So for our first tricky bug, we had problems getting the first monster to load. So we ended up getting this to work in the update. So one of our original problems was we didn't know how to get the monster into to save into component. We were then able to fix this by creating an array list of all the monsters that we would need to draw on to the game itself. We also had a problem where we originally were creating too many monsters, or that the monsters weren't moving. We fixed this by having it get the list of monsters that the game file created, and then have them print in our main component so that it would update with their movements instead of in the level loader where it got the level design.
The next tricky bug that we had was sort of creating the movement boundaries that we had. If we go to the player class here, this is the main class that accomplishes the main sort of for loop within a method that accomplishes that. So the way we designed our platforms is we originally loaded them from the text files where we designed the levels into our level loader. The level loader would then create an array of strings that was designed to replicate the different characters in the text file. And from there, a method within level loader would then generate an array list of sort of platform dimensions. It'd have the X and Y coordinate of the top left corner, and then have the width and the height. And based on that array list, which is platforms right here, this method then dictates the movement boundaries of a player. It also is inside the monster classes too, because those are moving around and they don't need to phase through different platforms. Basically what it does is it just makes sure that if based on the current movement of an object, if it would phase through it, then it stops that and corrects the movement to what it should be.
So for our lessons learned, if we had to recreate this project, we would make greater use of inheritance instead of only relying on interfaces. So for this, we had interfaces for character and egg. So for our character interface, we had the player, Monster 1 and Monster 2. So we could have used the interface for character for just player and monster, and had monster inherit to Monster 1 and Monster 2, because Monster 1 and Monster 2 were very similar in what they did. They were just different in the type of monster, but they had all of the same methods within them. And then for the eggs, we should have used inheritance for them as well, because they are both very similar and just do the same thing, but for their separate monsters. So just for Monster 1 for egg 1, and then Monster 2 for egg 2. So our biggest surprise was how difficult it was to get collisions to work. Get to the code real quick. So for our collisions to work, we had to get a lot of if statements going with a lot of ands in them. So we would have to check a lot of conditions to make sure that it was only colliding at a certain time, and that it would only hit once and not just hit for every millisecond that the two were colliding with each other. So basically, we had to set up a lot of different methods in classes that we weren't expecting to have, which is partially why our final design was so much more complicated than we originally expected it to be. So we also found out that you can create a array list of array lists, which is what we used for bullets. So for each bullet, we would have Monster 2 would have an array list of the bullets it had shot. And then since we had multiple Monster 2s, we needed multiple array lists of bullets. So we could keep track of all of the bullets for all of the monsters for our draw on method, so that they would all show up on the final game. So this was just a fun fact that we found, because we did not know that you could create an array list of array lists.
And that is the end of our presentation. We had some fun creating this project, and it allowed us to really flesh out our coding skills. Anything else you want to say, Reese?
That sums it up.
All right. If you are at this part of the video, I just would like to remind you to subscribe and to smash that like button. Thank you and have a good night.